The Leaning Tower of Pisa, one of the most iconic landmarks in the world. Construction began in 1173 in Pisa, Italy, and it started to tilt almost immediately. The initial design was ambitious, aiming to create a grand bell tower for the cathedral. By the time they reached the third story, the ground beneath it began to give way, causing the structure to lean. Pisa is built on soft, unstable soil, like building a sandcastle too close to the water. This soil was not ideal for supporting such a heavy structure. The ground wasn't strong enough to support the marble tower evenly, leading to its famous tilt. Clay compresses more than sand, causing one side to settle more. This differential settlement was a major factor in the tower's lean. Construction was interrupted by wars, and when resumed in 1272, the lean worsened. The long pause did not help in stabilizing the structure. Builders tried to compensate by making new stories taller on the sinking side, giving the tower its unique curved shape. This was an attempt to correct the tilt. Despite these efforts, the lean continued. The tower's tilt became more pronounced over the years. By 1817, it leaned by about 4.9 degrees, becoming a popular tourist attraction. People from all over the world came to see this architectural marvel. Engineers and historians worried about its increasing tilt. They feared that without intervention, the tower might eventually collapse. By the 1990s, the tower's tilt reached a dangerous 5.5 degrees, alarming experts and the public alike. Fears of collapse led to its closure in 1990, as authorities scrambled to find a solution. An international committee of experts was appointed to save the tower from imminent disaster. In 1993, detailed calculations revealed that the structure could only withstand 7% more stress before failing. Temporary measures included installing a sophisticated monitoring system and placing massive counterweights to stabilize the structure. A concrete ring and 600 tons of lead ingots were strategically placed on the north side to counteract the tilt. This intervention reversed the tilt slightly, buying precious time for more permanent solutions. The monitoring system provided crucial data on the tower's movements, allowing for real-time analysis. Engineers used this invaluable information to plan further interventions and ensure the tower's safety. The counterweights were a small but important victory in the ongoing battle to preserve this iconic structure. A permanent solution was needed to address the persistent lean of the Leaning Tower of Pisa. The structure's stability was at risk, and engineers had to come up with a method that would ensure its safety for future generations. After much deliberation, the committee settled on a technique known as under-excavation. This involved carefully removing soil from underneath the north side of the tower. The idea was that this controlled subsidence would gradually reduce the southward lean of the tower, making it more stable. In 1995, engineers tested the process on a concrete footing to ensure its feasibility and safety. Despite initial setbacks and challenges, the method proved to be effective, giving hope to the restoration team. To further ensure the tower's stability, an elaborate safeguard system with steel cables was put in place, adding an extra layer of security. In 1999, engineers drilled 12 boreholes under the north side of the tower as part of the under-excavation process. Over the course of 5 months, small volumes of soil were meticulously removed to avoid any sudden shifts. This careful process resulted in the tower's tilt being reduced by about 0.04 degrees, a significant achievement. The main intervention, carried out between 2000 and 2001, involved drilling 41 holes and removing 38 cubic meters of soil. By the end of the project, the tilt was reduced by nearly half a degree, significantly increasing the tower's stability and ensuring its preservation for years to come. The under-excavation reduced the tilt by nearly half a degree. This returned the tower to its early 1800s inclination. The 600 tons of lead counterweights were removed. A new drainage system was installed to control groundwater levels. The tower was structurally connected to the Catino, increasing foundation stability. Engineers decided not to straighten the tower completely. Its iconic lean is part of its identity and history. Today, the Leaning Tower of Pisa stands stable and safe. It remains a monument to medieval architecture and modern engineering. The tower continues to charm visitors from around the world,